Assalamu alaikum. Today we're going to start with the chapter Thermal Energy Transfer. So, what is heat energy? We need to understand that heat or thermal energy will always flow from a region of higher temperature to cooler temperature. Okay, so over here you can see if there is a hot object and cool surrounding, heat will move from the hot object to the cooler surroundings. Or if we have two objects that are joined with each other, that are touching each other, and one of them is hotter, the other one is cooler, the hotter one will keep on transferring its energy to the cooler object till both of them are at thermal equilibrium or at the same temperature. Okay, now how are they going to transfer this thermal energy, this heat energy? Through three processes: conduction, convection, and radiation. Let's have a look at what these three processes are. We'll start by conduction. So, conduction is one way how the molecules are transferring from hot to cold region. Conduction is the transfer of thermal energy through a medium without any flow of the medium. The medium will not flow, but the thermal energy will flow. So, when a molecule is heated, let's take an example of this rod where the portion where it says hot is actually there is a heat source. For example, a flame. This rod is brought near a candle. What happens? The molecules inside the rod begin to vibrate. We know that when a molecule gains kinetic energy, the molecules start to vibrate. The intermolecular forces, the forces between two molecules, are allowing these molecules to vibrate and pass on the vibration to another molecule by bumping into them. Now, if the forces are stronger between two molecules, the vibrations are going to be faster. And that is why solids are the best conductors, because they're the closest, they have the strongest intermolecular forces, and gases are the worst conductors. A worst conductor, a poor conductor is called an insulator. And since in conduction you can see that molecules are required, so you cannot have conduction in a vacuum. Let's see how conduction takes place through metals. Now, metals have an additional method of conduction. Not only do the molecules vibrate and pass on energy, they also have free electrons. You have studied in chemistry that every atom of metal has free electrons that form a sea of electrons. Now, these metals have a sea of electrons that can move freely from one atom to another, and hence they can pass energy through metals very quickly. So the hot atoms are vibrating and slowly passing on energy to the colder atoms, but free electrons are quickly moving in between these atoms, disturbing the arrangement and passing on the energy towards the colder regions. That's why metals are the best conductors. Despite that, diamond is a non-metal, but still it is the best conductor you can have. Now, why is that? Because it has such closely knit structure, such a closely knit structure, and even though it uses the vibration method in which the molecules vibrate, it still has the best conductivity. Now, let's see. How can you increase the rate of heat transfer in conduction? You can use a better conducting substance. If you're using plastic, you can replace it by metal. You can decrease the thickness of the substance, which will decrease the volume. You can increase the area, the surface area of the substance, so the more of the substance will be exposed to heat. Or you can increase the temperature difference. For example, first the difference was 60 minus 20, 40. You increase it to 100 minus 20, 80. When the difference is faster, the rate of transfer increases. How do you find the best conductor? Right, so over here you have a lot of rods that have the same length. We are keeping all the factors constant so that we can find our variable, our dependent variable. Now, they all are being heated equally by the same Bunsen burner, but there is paraffin wax at the end of each of these rods. So now, when the end of these rods reach a certain temperature, when they reach the melting point of the paraffin will melt, and the paraffin is joining a matchstick to the rods. That matchstick will fall off. So whichever rod has the matchstick fall off first would be the best conductor. According to that, copper should be the best conductor, which is why we use copper wires. Water is a poor conductor. If I take a boiling tube of water and heat the top of the water, if you want a convection current, if you want proper heating of water, you will always heat it from the bottom. But now we're heating it from the top. So the water begins to boil at the top, but the bottom of the tube remains cold. Had this been a rod and I would have heated the rod from the top, the bottom would also have started to gain heat and become hotter, and it would not remain cold because they would all transfer the energy quickly to the other side as well. But since that will happen very slowly, only the top part of the water, the surface of the water will boil and it will leave as water vapor. The bottom part will remain cold for a long time. That shows that water is a poor conductor. Let's move on to convection. Convection is the process of thermal energy transfer in fluids. What is a fluid? A fluid is a liquid or gas. How does convection take place? Convection takes place through convection currents. Now, what do I mean by convection current? The warm fluid, when the fluid is heated from one point, that will rise. And when that place will rise, why will it rise? Because it's becoming less dense. If this woman, the top air is getting heated, what happens when I'm heating any fluid? They will gain more kinetic energy, they will move further apart, the volume will increase, and hence, using the formula, we know that when the volume increases, the density will decrease. When the density decreases, it's less dense, it's lighter, so that fluid will rise up. So when a heated fluid, a heated liquid or a gas, some bulk of those molecules are rising upwards. This bulk of molecules rises upwards, it's going to be replaced by cooler molecules from the sides. Cooler molecules from the sides are going to come up and fill that space when those warm molecules rose from the bottom and upwards. That is called a convection current, and that cannot occur in solids, only fluids, that are liquids or gases. Now, convection in water. Over here, you have potassium permanganate crystals. You will see those crystals forming convection currents in this shape when you heat it. So you're heating it from the bottom, you're heating these potassium permanganate crystals. This bulk of water molecules over here near the heat, they are going to gain more energy. Uh, they're going to move faster, they will increase their volume, they will get less dense, they're going to rise, and they're going to be replaced by these bulk of cooler molecules at the top from the sides, and they're going to replace them. Then these cooler molecules will be heated, they will rise, and in this way the whole liquid is going to be well heated. That's why the potassium permanganate dye is going to rise and then sink, and then rise and then sink and fall those convection currents. Why is the water sinking from the sides? That becomes more denser as comparison in comparison. So the denser molecules are going to sink. Now, this is called a boiler or the heating systems at home. What happens is you have this boiler that is heating the water. That water is rising and going to the top of the storage tank because it's less denser. And the cooler water is sinking because it becomes denser in comparison and goes back to the boiler, so it's heated again. Over here, when you open the tap for hot water, the water is going to come out. When this water is getting heated, its volume is increasing, so the water is increasing in amount. From here, this cold water is moving on to this tank that stores extra water, and this expansion pipe, this extra pipe, is going to collect any water. If this hot water is rising, it's expanding, the volume is increasing, so if it increases too much in amount, this expansion pipe is going to take it to this storage tank. that in a hot day, the heated air will rise from land, and then because the land is warmer than the sea, and the sea breeze will replace that when it rises. And at night, it's the opposite. The sea is warmer, so heat will rise from the sea, and air from the land will fill that space. And so that's called land breeze. The above in the day is called sea breeze. Let's move on to thermal radiation, which is also called infrared or IR radiation. That happens when heat energy transfers through electromagnetic waves or electromagnetic radiation. That can take place without any medium, because electromagnetic waves do not need a medium for transfer. Hence, this is the fastest form of heat transfer. It's the only type that can travel through a vacuum, and gases will allow best radiation as compared to liquids and solids. So how can we feel thermal radiation? If we bring our hand closer to heat, we can feel that heat through radiation. The hotter an object is, the more radiation it gives. If the object is dark, if the object is black, it's going to emit better. If it's dark and dull and rough, it's going to emit better. If it's polished and shiny and silver, it's going to emit worse. If it's dark and dull, it's going to absorb better. And if it's shiny, bright, or silver or polished, it's going to absorb worse. Now, that's why a kettle will absorb and emit heat much slower as compared to those kettles that are dull and black. In a vacuum flask, how is conduction? Because we want to reduce heat thermal energy loss, so loss of thermal energy. So how will we reduce conduction? By the stopper, by the glass, the cork, and these air spaces. How are we reducing convection? Because there is a vacuum stopper in between and the trapped air spaces. And radiation is reduced if that is painted silver or it has a polished cover. Moving on to the applications of these three methods of thermal energy transfer. Firstly, conduction. So that can be used in electrical appliances. For example, the handles of kettles, pans, etc. are made of insulators so that heat cannot be conducted to your skin and your skin doesn't burn. Then we have the application of convection. That is, for example, fridge or air conditioners. So the cooling compartment of the fridge or the freezer will be placed at the top, so that the cool air from there that will cool, that will sink, and then it will be replaced by the hotter, less denser air from the sides that will move to the top. In radiation, in the refrigerator, you will paint those cooling fins black and they will be rough, so that that becomes a good radiator of heat that will keep your fridge cool, and so all the heat would be easily emitted by those cooling fins. Another thing we need to have clear, why do we have the air conditioner at the top and the heaters placed at the bottom? Why do we have our fireplaces at the bottom and the cooling compartment of the refrigerator at the top? That is because if it's the other way round, for example, the AC is placed at the bottom, what will happen? The bulk of air molecules will get cooled by the AC, they will become denser and they will sink and they will remain at the ground. So they will not move upwards, so there will be no convection currents. The top will remain hot, the bottom will remain cool, so it's ineffective.